This video is on sine diagrams. So we can determine intervals for which the function is increasing by creating a sine diagram of the derivative function. So when we look at this graph off to the right, it's increasing in this region and has a positive slope. So the notation we're going to use is that the derivative function is going to be greater than or equal to 0 because our gradient is our slope. We're going to have a positive. Moving to the right, again, this is decreasing. It has a negative slope. So how we write that is the derivative function is going to be less than or equal to 0 for all x's because the slope is negative. So here are the steps to create a sine diagram. We're going to find the derivative of the function. So remember that is your f dash x or dy dx. Step 2, we're going to find the critical values for which the function equals 0. That means we're going to solve for x, and sometimes we're going to have to factor. Step 3 is we're going to set up a sine diagram with positive and negative slopes. We're going to evaluate the derivative for test points. And when is the derivative positive or negative? Step 4, we're going to draw a rough sketch or use our graphing calculator, and then write the intervals for which it's increasing and decreasing. So here's some examples of some sine diagrams. So the first example is a quadratic function. Here is the shape of that graph. And we find the derivative using our power rule. So we're going to bring down the 2. So our derivative function is 2x. Now we set the derivative function equal to 0 and solve for x. Well, 0 divided by 2 is 0. So 0 is called our critical point. So here is 0 on our sine diagram. And then what we want to do is we want to test a point to the right and see what our slope would be. So if we go, say x is 1, and we substitute f dash of 1, 2 times 1 is 2, that's a positive. So to the right, this is going to be increasing because the slope is positive. Now let's try something in the interval on the right of our critical point. So we substitute f dash negative 1 in. So 2 times negative 1 is negative 2. So our slope is a negative. So that means it is decreasing to the left of 0. Now we can write the notation for our function. So here's our function. It is decreasing when it is less than or equal to 0 for x, and then it's increasing when it is greater than or equal to 0. And this is what we call the sine function in that box. You're welcome to look at this example here. I'm going to move on to a different one. So here is our cubic function. There is our graph of our cubic function. And we want to find the derivative, so we'd use our power rule. So there's our derivative function. And then we find the critical point. So we set the derivative function equal to 0, and we solve it for x. So we divide by 3. And then we solve it, so we substitute 0 on our sine function, sine diagram. And now we're going to, I'm just going to change colors here, test a point to the right in our derivative function. And we get a positive, so that means our so here would be 1. It's increasing the entire interval. Now let's try a number to the left of your critical point. So f dash of -1. So 3, replace that x with -1 in the derivative, and we get a +3. So the slope is also a positive. So what does that mean for our function? It is increasing over the entire x values, the all real numbers. You can look at this next example if you'd like.